So the first presentation will be by Adrien Albouy and Stéphane Letz about Faust audio DSP language for JUCE. Adrien and Stéphane are working at GRAME in Lyon.
Yeah, so I'm going to present you what I did during my internship at GRAME. I'm no longer working there. It's been an internship of 5 months from September to beginning of February. And we've been working during these 5 months with Stéphane on the adaptation of the Faust language being adaptable to JUCE. So I have personally worked on the graphical adaptation of it, and Stéphane more on the audio. So during this presentation, I'll be introducing a bit into the context. So what is JUCE? What classes do we need to know about JUCE to understand the basics, and how Faust architecture files works. And after that, I'll explain my work, so the layout algorithm. How do I handle the adaptation from the Faust UE logic to the JUCE component logic that I introduce. And the audio adaptation that Stéphane worked, there will be a quick word. And there will be a demonstration and then conclusion. So to begin with, JUCE, as most of you know, I guess, is a C++ framework developed by Rowley. It's open sourced, and it has the advantage on other frameworks to be really audio orientated. So why adapt Faust to JUCE? Because the main goal of it is to maintain only one code on JUCE, and JUCE handle the export to the multiple platform, desktop platform like Mac, Windows and Linux, and mobile devices, iOS and Android. I'll be talking about the JUCE component class that is pretty important for you to understand that what I will be talking later about my layout algorithm. The JUCE component class is the main class that handle graphical element in JUCE. Everything that will be shown to the screen is a component. It has an architecture in a tree form, like with a parent and a child, pretty basics. A bound of a component is relative to its parent, is x and y coordinate, and its width and length. The two main functions that are available for us to work on a layout is the paint and the resize method. The resize method is called every time we are changing a component bound. We are setting new x and y coordinates or changing its width and height with a resize of the window, things like that. And the paint method is called whenever a flag indicates that the current element needs to be redrawn, like a mouse cursor being on top, or a click, or a resize, for example. And a big part of it is the customizability of the look of the appearance of the different widgets. Like you can see there that there are layouts that looks a bit older and more recent layout. It's really easy to change that. So, Faust architecture file. I'll be talking about the UE and GUI architecture file, like the graphical ones. In Faust, we have widget-based logic. We have active, passive, and layout widgets and tabs that are a bit different. Active widgets are the one that controls data, like a slider, a knob, or just an entry. Passive widgets are there to display data, like we have a viewmeter or simply box with value in it. And layout widgets are a logic of boxes, like different active and passive widgets will be in boxes. Like we can have there, for example, we have a boxes containing a knob, an entry, 2 vertical slider, and a viewmeter. And the big part of it is the metadata. The metadata allow us to declare more to those widgets. We can declare if a DSP is polyphonic, for example. Like we can hard-code the DSP to be polyphonic with a certain number of voices. That can be overwritten, but it will always be a polyphonic one. And we can declare like different style. A knob, for example, is in the Faust logic a slider with a metadata of style knob. It will be displayed as a knob. We can display, as it's shown there, the unit and set it to be F for example, or Hertz, as it's shown. And so, knowing that, how do I handle to manage the layout of a Faust module in JUCE? So we use different stages of components. Like we have a base component 1, which is there called UE base component, but now called UE base, where there is that is defined by its width and its height, its display width and display height that I will get to later. We have a logic of ratio, horizontal one and vertical one, to know how much space it occupies in this box. And that's pretty much it. There it's only calculation about where to place and how to place, how many size it will be using. And so we have two big parts of that the UE boxes, that is the layout widgets of the UE, the Faust architecture file, and the UE components that will be active and passive widgets. It can be like the UE slider class that you can see just on the other side, sorry. Can be a horizontal or vertical slider, a knob. It's a big regroupment of different kind of slider. And the UE component handle passive and active widgets. So there. How the layout is initialized. In the DSP compiled with Faust, we have a build user interface that is defining how the program has to be shown. For example, there, a simple interface like that is a horizontal box, which means that the widgets will be displayed horizontally in it, with 4 sliders in it. The code will be open horizontal box, add vertical slider 4 times, and close box. That's pretty much as simple of it. And while parsing this build user interface method that we are parsing at the initialization of the program, then we are building our tree, defining each widget to be a child or the child of what parent, what box, and handling different level of boxes. Once we are done parsing this build user interface, there is another part of it, which is the initialization of the ratios. There, as an example, just imagine that the title 1 box is the whole interface. And in it, we have 4 sliders, which there occupy the same width. So the box is 1, and each slider occupies 25% of its width. So their horizontal ratio will be 0.25. If there were only 3, it will be 0.33, etc. Once we know that, we have our ratios and our sizes set. We need to display the different widgets with the good size and the bit of margins for it to be readable. So let's stay with the only 1 box and 2 widgets in mind in there. So in first we have just a row rectangle that is basically end xy 0 and a width of the width and height of our window. There, the first thing to do is to check if the box needs to have a title, and if so, we display the title, and we remove every time we do something on the box. We remove it. Like we are giving the title, let's say 12 pixels there to be shown. We are removing the red part of it on top to be sure that nothing will be displayed there because it's the place of the title. it lets us with the big gray rectangle that we have. And then we are deleting the 2 pixels merging that we are considering, just to not have elements that are really close to the border of our window. And then we are allocating for each child widget the width and height that it needed. There it's an horizontal box, so we need to allocate width. I did a pretty simple example there with only 2 items, with one having a ratio of 0.7 and the other one 0.3. So the first one will be given its size, and this size will be removed from the massive rectangle that we have at the beginning, just to be sure, one more time, that we don't display anything else there, only one thing at one place. And the next one, the rectangle, starts about there in the middle, a bit too high, and we are giving it its width, that is 0.3 times width, and we are translating it for it to be shown with its proper margins. And there, it's a pretty simple example there, but we have a functioning layout system which is dynamic and can be resized at pretty much every moment. So that's it for the graphical interface part of it. About the audio, so about what Stéphane did, it was a simple matter of connecting our Faust logic to the JUCE logic, like plugging the DSP audio chain in a plugin or standalone mode, depending on what application we are developing. And for now, it's including MIDI and OSC support. So we have basically do a glue between the both. Pretty much how we did it's just a matter of translating from a Faust language to JUCE language and adapting it. So we developed a Faust to JUCE script for it to be really easy to use and pretty much ready to use at any moment and self-contained. With a simple line, Faust to JUCE, with our DSP, we are obtaining ready-to-use JUCE project that we just have to put in a JUCE logic, in a JUCE folder logic to be ready to use without any setups. For now, it's handling the widgets and application, the widgets and standalone creation. We can do both. We can override the polyphonic mode that can be declared in metadata if we have declared metadata, but we can do pretty much a polyphonic mode whenever we want. We can add effects, which are already in the Faust logics. And if you want to use MIDI or OSC, we have options for it. This Faust JUCE script is already available too on the Faust online compiler that I'll be using later during my demonstration. So to show the online compiler, which is there at this URL, you basically just drop a DSP that is just there. Let's say we're gonna using the electric guitar that Romain Michon did. You just drag and drop it, and then it compiled in whatever you want, and you give it a name, so guitar, for example. Selecting the JUCE and let's say it's a standalone, and it's pretty much ready to download and to use. There we have our compressed file. I'll just take the folder, and we have to give it to the example folder of the JUCE Git. Just to show you, there. This is the folder that you can download on the JUCE Git. You just put it there. And you have two files, a CPP that is self-containing every Faust that we need, and a juicer that is the JUCE thing. We are just saving it for it to generate every export solution that we can get. And we have our Xcode project that is ready to compile. So, this application is MIDI control. So I have no MIDI keyboard, so it's working without MIDI control, just as a generator. But I'm not sure. Yeah, don't worry. I'll show you with another program using the Faust JUCE script. So, if we want to use a Faust JUCE script, it's just done as, there we go. So there, it's a terminal already in this folder. So I just have to type Faust JUCE MIDI for it to have MIDI support, and voices 8 to declare it as polyphonic. And let's do the same, guitar MIDI. And it has curated us, just there, another folder that we can find on the online comparator. It will be the same thing, but with MIDI handling, so I can demonstrate how MIDI works. There we go. While it's compiling, I'll show you another example that we pre-compiled, like cubic distortion that is a big user interface with a lot of different elements. Like there, we have a lot of ViewMeter and everything like that. It's perfectly working with the ViewMeter actualizing in real time and different parameters that we can play with. It's done compiling, so there we have our MIDI ready to be controlled application. I'm just checking that it's connected to the MIDI support. And there, I closed it. We can control it with a MIDI keyboard that is there emulated, but it works. And just to show you, do we have another thing to show you? No, I think it's pretty much it. But yeah, let's get back to the presentation. And to conclude, though, this presentation, the Faust JUCE adaptation is pretty accurate on the audio aspect and the graphical aspects. And in terms of CPU usage and consumption, it's pretty comparable to our already native scripts like Faust to iOS, that is, or Faust to Android on mobile devices, and to other frameworks export on desktop. And so the adaptation of Faust on the JUCE framework have a bright future in front of him, I guess, because it will let us control only one code and maintain one code, and it will be easier in the future for us. So, sorry about this presentation. I'm a bit nervous. It's my first time doing this. So, I've been a bit quick, I guess, but as we are late, it's perfect. So, if you have any question, I'll answer it as much as I can, but I'll do my best.
Chance, Albert.
Thank you. And one question concerning the LV2 backend. Do you know whether that's supported?
Sorry?
The LV2 backend of JUCE, because Philippe did this a while ago. I'm not sure whether it's actually been in the official JUCE repos yet, but it's available. So would be nice to have to be able to produce LV2 plugins that way as well.
I guess, Stéphane.
At least on Linux.
Oh, yeah. I guess, Stéphane, we answer on the audio side of it. Oh, sorry. You will answer that.
I can comment a little bit. The JUCE project has not accepted the codes, and they say they're not accepting it right now for several reasons, but there's a fork of the JUCE project that you can use instead of your normal one, so which provides
replacement then and then
yeah, it's exactly the same code, just with some extra things. There's nothing in the producer or the producer that exports directly to LV2, but I can add that as well when it's needed.
You're pulling in the changes from
yes.
upstream all the time. Okay.
Yeah, just if it's outdated, just ask me, and then I'll do a git pull, and things get merged and start working again. Yeah.
Where can we find that?
GitHub distro JUCE. Yeah.
Hi, thank you. Sorry, you mentioned that JUCE is an open source library. I've just looked at their website, and it's very confusing about their licensing terms. So there are different offerings, some cost something. There's a free personal option that has a splash screen requirement, and if you exceed 50,000 in revenues, you have to convert to GPL3. Which hints at that JUCE might be under GPL3, but actually I haven't understood the licensing. Perhaps you could clarify a bit.
Yeah, on that, we have spoke about that with Stéphane just before.
When they released recently the 5.0 version, and as you say, as I understand, you can use it as a personal or educational system up to a point where you start to make money with it, and then something is changing at this point with a kind of threshold, as you say. But I don't know exactly the detail of how they change the licensing in the recent.
But this does not sound like open source.
It's
JUCE
GPL,
is open source.
But the way they charge people that commercialize the resulting application is, well, I don't know exactly the detail, but as I understand, the source is still GPL, yes? Yeah.
If you have other questions for other people to answer. No? Okay. Very good. All right. Thanks, y'all.